Hello and welcome to Physics 2426. I'm glad to have you with me for this online summer course. Now, we're all coming from different University Physics 1 experiences. Some of you might have taken it online or in person. You might have taken it in a full-length semester or during summer in a shortened course. And some of you might have had it from professors that you thought did a good job or didn't do a good job, some that maybe did a lot of calculus, some that did almost no calculus. But one thing that we have coming in here to University Physics 2 is this is usually the harder of the two courses for most students. Mechanics is very concrete. If I'm looking at projectile motion and I want to figure out what's going on, I can toss a ball, I can roll something off the table. Now, with electricity and magnetism, it's a lot harder. Oh, here's this electron. I'm going to move this other electron close. What happens? Hard to visualize. But there are a lot of online tools that will allow you to kind of visualize the different three-dimensional spaces that are going on. It's also field-based, which means you're looking at these complicated 3D wibbly wobbly spaces, some of which don't physically exist at all. We're just putting them in place so that we can do calculus. And there will be more calculus than you probably saw in your University Physics 1. Now, this causes problems when we're taking this course online in summer because we have to take this difficult 16-week course and compact it down into really only a little more than 5 weeks. It's not even 6 full weeks. So we have to make sure that we're communicating with each other. So I'll do my best to communicate with you, but if you're struggling, you need to reach out to me. You need to reach out to your classmates. The discussions are a good place to do that so that you can get and give help in a timely manner. Now, I'm going to kind of walk you through D2L and how I have the course set up, because this course might be set up in D2L a little different than you had in another course, and I want you to know where to find everything and what my expectations are. Now, this does not replace reading through the syllabus and reading through all of the information that I have. This is just the highlights. So what I have here is I have the student view of what you can see right now. So the most important thing are the announcements tools right up here at the top. And as you scroll through, I have a lot of initial detail. You will find that there's a lot of detail in here that I repeat over and over and over again. If I'm doing that, if I'm repeating myself, it's because it's important. And it's something that a lot of people through the past years, as I've taught online courses or I've taught electricity and magnetism, that people have just forgotten, skimmed over, and has caused them problems later on. So there is a to-do list, but I caution you, please don't use this to-do list as your guide for the week because it only gives you assignment deadlines. But we can see that there is your introduction discussion is due on Sunday night. That was normally due on Friday, so I pushed that back a little because of Barrel. And then the syllabus quiz was normally supposed to do the first day. I've pushed that back to Monday. And you do need to make sure that you've at least attempted that to count as your official attendance. But you cannot access any course content until you have finished that syllabus quiz at 100%. It is very detailed. I suggest you have the syllabus quiz and open at the same time as the syllabus document, because there are details, and I'm not trying to trick you, but I'm making sure that you've got all the important stuff, because the pieces that I've highlighted are the pieces that people have forgotten about, and then they're like, oh, I didn't know that was due then, or I didn't know that's how it was graded, and it's caused problems later on. And then you can also see that the first lab, you're supposed to work on that on the first day, but I've extended that deadline also from this Sunday to next Sunday to account for Barrel. So you've got that there, and then you've got your quiz. That is your syllabus quiz. But you're going to access most everything that you need from content. So if I click here and go to content, I can go to the overview, and the overview is the syllabus. This is not the final version of the syllabus, but I will have the final version of the syllabus there for you. And then if you go to the syllabus quiz, you can see that you've got another copy of the syllabus here and then the syllabus quiz there for you. And then that's really all you can see besides the formula sheet and my favorite tutorial resources here for you. So how do I get to the rest of the content? Well, once you have finished the syllabus quiz at 100%, you will see more in the modules. So what I'm going to do is I'm going to leave the student view so you can see what the rest of the course will look like. So this is what I see on my end, so it's a little different than yours. But now if I go to content, I can see that I can see Mastering Physics. There's the formula sheet, tutorial resources, and then here is Module 1. Now, I am currently updating this course for being online in summer. I've never taught this particular course online. Usually I do University Physics 1 online in summer, but they had me switch over to University Physics 2. So I'm having to convert everything. So if you, at any point, you do see something that's referring to an in-person lab or an in-person due date, please send me a message and I will fix that and update it. I'm going through and doing that as I go. But if I click on Module 1, this is what you'll do as soon as you're done with your syllabus quiz. The first module overview is very detailed because I'm introducing you to everything. If you look at the syllabus, there is a calendar. And with that calendar, there are suggested dates to do all the different sections. So these sections and the dates that it correspond to are here on the left. So section 1 is what you're supposed to complete on Thursday, 7/11. Now, not everything is in that section is due on that date. That's just the date that I recommend that you work on it to help pace you through the course. So with that, you have those dates, and then they're kind of giving you an overview. Once again, some of this is in the syllabus, some of it's more detailed than the syllabus, but I've got kind of the lectures and videos, which I'm getting uploaded for you. The details for Mastering Physics. When you click on Mastering Physics, it'll take you in to Pearson and it will have you go through and pay, or it might let you do a couple of assignments and then make you pay kind of as a little trial period. But you'll have those assignments there for you. It's set up so that you have every section has a homework assignment. On average, they'll take around 2 hours. I know it sounds like a lot, but remember, each one of those is 2.5 course meetings worth of content if this was a 16-week normal course. So it is going to be a lot. And then if you don't get a 90% on it, it will generate this adaptive follow-up. That adaptive follow-up is not required to complete, but if you get a 90 on the original assignment, or if you don't get a 90 on the original assignment and you get a 90 on the adaptive follow-up, that gives you part of the extra credit towards the final grade. So this course is hard, and in such a short amount of time, you may not be able to make an A or a B on a test straight up. And so I built some ways in there for you to kind of make up for that. One way is to actually have your final exam replace your lowest test grade. The other is your homeworks. A lot of you do your homework, you do it well, you take the time to do it right, but you still struggle on the tests. So this is a way that if you get in good grades on your homework, 90 or above, or on the adaptive follow-up, that you can get 5 points of extra credit on your final grade. So that means if you're sitting at an 85 and you do 90% on all of your homework assignments or on the adaptive follow-ups, that's going to get you an extra 5 points. So that can bump an 85 to a 90. But if you don't quite get every single one, so say you had a couple of bad weeks and you only managed to get half of them done at a 90 or above, you can still earn 2.5 points of extra credit, or whatever the prorated is. So anywhere from 0 extra credit to 5 points of extra credit on your final grade for completing your homework at a high level. So that is going to help you out. So a little detail on the Mastering Physics. With your discussions, the discussions are a way for you to get help and give help. And it's another way that you can earn points for this course without having to do well on a test. Sometimes when people get really stressed on time, they skip the discussions, but they are worth 10% of the final grade, and they're not dependent on your ability to do physics correctly. But You have to follow the rubric, and the rubric's in the syllabus, and you have to get those done on time. So there's 2 ways to get to the discussions. If you scroll down in the module, the discussion for the week is at the bottom with more details and suggestions for what to do. Or you can get to them by going to collaboration and getting to the discussions. So you can see the introduction discussion and then discussion 1. So I do strongly suggest that you favorite these. I think you can click on the discussion and then you hit subscribe. And I have the subscribe. I get an instant notification whenever someone posts. And that way, if I've posted something and I'm trying to get help, I'll get notified. Or maybe I'm not the type that likes to be the first person to post, and I just want to kind of wait and see what people have done. You can see if anybody else has posted, and maybe you know an answer to their question and can get help. I do teach physics full-time in high school as well, along as being a professor. So starting in August, beginning of August, I go back to full-time teaching. And I'm not going to be as available to answer questions during the day. I'll do most of my work for this class at night. So having the discussion gives a chance for you and your classmates to help each other out. Also, if you ask a question in the discussion, that gives me a chance to answer the question in the discussion so everybody can see, rather than having 10 of you send me the exact same email with the exact same question. Now, if that happens, I'll generally post an announcement, and so that way I can update everybody if I'm getting the same question, or maybe I've made a mistake somewhere in the course. That'll give me chances to clarify. But those discussions are important, so please make sure you actually go through and do them. So going back to Module 1, we got our video lectures, mastering physics, discussions, and then labs. So we will be doing virtual labs. I've done a lot of these labs before during COVID and so forth, but a few of them are new. So if at any point in time you're unsure of a lab instruction, or not quite sure if you're doing things right, or you're not sure if your results are correct at all, that's where those discussions go into play. Post your work on the discussion. This is what I've done. What do you guys think? Or I got this result. Is this supposed to be a linear graph? Because mine's not a linear graph. What did I do? That's a good place for that. So there's 2 options for this. Each lab has a handout with questions that you fill out as you go. You do have to handwrite those answers. You can do that either by printing out the handout or by using digital capture your handwriting. But you cannot type, you do have to write. And you can't write and then convert to print because that just confuses everything. I do want to make sure that you are working through and doing your answers. That's part of science, is documenting your work. You will also do a graphs. So we're going to be using Vernier Graphical Analysis, which is a free app, and there'll be instructions in the first lab for how to use that. But it's a nice, easy way to get graphs that look good. Additionally, it has more advanced data analysis that we can't do using Google Sheets and Excel. I know those are kind of a standard for a lot of physics courses, but there's at least one lab for sure where the curve fitting we need is not an option on Excel or Google Sheets. Vernier Graphical Analysis are our only option for that. So there'll be instructions for how to use that. And then you will also type a conclusion, which will summarize different parts of the lab, which will be about a page long. And then you put all of that, you make PDFs of everything, put it all together into one single document and turn it in. This is really important. One single document. So you don't have a document with your handout. You don't have a document with your graphs. You don't have a document with the conclusion. You have a document that has everything in, as if I was handing you a lab to turn in. I use Adobe Scan for that. It's free. It's really convenient to use. And I have Adobe Acrobat, which will allow me to merge PDFs. You should also be able to access that with your Lone Star email. That's how I access it. So you can check on that. If not, there are tons of free apps online. Some have limits on how many documents you can merge, but this is really common. Also, it's a really good skill to have if you're going on to the real world. Please crop all of your images and everything so it looks very professional. Good skill to have for real life. Now, additionally, some of the more difficult topics, I've written derivation packets. I did these for my in-person AP Physics C courses because there's a lot of calculus in this course compared to University Physics 1. And we're doing this in such a compact way that instead of having these as assignments that you complete and turn in, I have them for you, and I will also have the answer keys. If I do this in person, normally the answer keys are available. You work together at tables, you come check your work, you go back and work and so forth, and eventually you turn the packet in, and then I give you the answer key. We don't have time for that, and they are difficult, so I will have those for you. The discussions are a good way. If you don't understand why I did something the way I did, take a picture, walk through what you've done, and then do that as a post. So now if I keep scrolling, I can see here's the sections. I usually, once I've read the overview, I go back up to the top and I access the sections here so I don't have to scroll as much. So section 1, this is what you're supposed to complete on Thursday. There will be lecture videos and tutorial video links here. Don't have those quite ready yet, but I'll have those ready for the actual course date. And then it tells you what mastering physics assignments you need to do, reminders how to access that, reminder about the introduction discussion, and the details, specific details for lab 1. And if I keep scrolling, here's the discussion link. Here's the PowerPoint presentation that goes along with lecture 1. Some of the lectures will have the where I will be me voiceovering the presentation. Others will be separate videos, but all of the lessons will have a lecture. It just might be, if I already have a video, I'm not going to take the time, probably this year, to redo a video if I've got the content already. Guide to data analysis. This is really important. There's more details about this in the lab information, and here's your first lab. So this is how you will access all of your information for this. You can check your grades through the grades, but that content tab is going to be the most important part, and then navigating along the sides on the left with everything. So if you have any questions, please make sure you send me an email or reach out in the discussion 1. And then good luck with everything. Have a great day.